Okay, so today we're going to look at now the conservation of mass. And after we complete this section, we would have completed chapter 3. So let's talk about the conservation of mass. There's actually a law called the law of conservation of mass. And basically, what that law says is that there's no change in the observed total mass of the substances involved in a chemical change or a chemical reaction. Another way of stating this is that matter is not created nor destroyed in a chemical reaction. So basically, what this means is that in a chemical reaction, whatever the amount of material you start off with, the same amount of material by mass will be the same in the product. All right. So to illustrate this, we look at the reaction between sodium and sulfur to form sodium sulfide. And in this particular experiment, what was done was that they weighed 46.0 grams of sodium, 32.1 grams of sulfur, and they did the reaction and they weighed the mass of the product. And what you'll find is that the total mass of the reactants will be equal to the total mass of the products. And this is generally true, in fact, true in most cases when it comes to any chemical reaction. The mass of the reactants will be equal to the mass of the products. Okay, so now we're going to get into a discussion of some terms that you need to be familiar with from now on into this course. First of which is elements. What are elements? Basically, the element or an element is a fundamental substance that cannot be broken down into simpler substances by chemical means. All right. So whatever the element is, you cannot perform any other further chemical reaction in order to break it down into anything simpler. And all the known elements on Earth, all the known substances on Earth, I should say, are formed from a combination of more than 100 elements. And of course, those elements are listed in the periodic table. If you get any periodic table, you'll see basically the list of known elements and their elements being synthesized pretty much every year. So there's going to be addition to those elements already on the table. So we're going to talk about the periodic table later on, how the elements are arranged and why they are arranged in that way. But before we get to that, let's talk about compounds. So we talked about elements. Elements are the most fundamental substances which cannot be broken down into simpler substances. Compounds, on the other hand, can be broken down or decomposed into two or more simpler substances, right? And some examples are shown here. Water can be broken down into hydrogen and oxygen, and table salt, which is sodium chloride, can be broken down into sodium and chlorine. All right. Then we need to talk about mixtures, right? What are mixtures? A mixture is a physical combination of two or more substances that can be present in variable amounts. All right. There are two types of mixtures in this regard. You can have homogeneous mixtures and heterogeneous mixtures, right? So a homogeneous mixture, which is also known as a solution, is a uniform physical combination of two or more substances, and it exists in one phase. So an example of sugar and water being mixed together is one of a homogeneous mixture, which is a solution, all right? Because when you mix the sugar with the water, remember you start off with something that is solid, with something that is liquid. When you mix them together, you end up with basically a solution which is liquid, right? There's no trace of the solid present excepting maybe the taste, which means that the sugar still exists, but you cannot see it. And you cannot distinguish between the sugar and water in the mixture, right? So it's a homogeneous mixture. And the reason why is because, as stated here, after mixing, the sugar is evenly dispersed throughout the volume of the water. And I'm quite sure you can name some other examples um, of solutions, of homogeneous mixtures, which we'll get into in class. Heterogeneous mixture. Now, this is a non-uniform physical combination of two or more substances. An example of this would be a mixture of sugar and fine white sand, right? In this particular case, the sugar and sand each retain their own properties, right? So that's the difference between a heterogeneous mixture and a homogeneous mixture. A homogeneous mixture is a uniform mixture, while a heterogeneous mixture is a non-uniform mixture. All right. Okay, continue our discussion. Well, actually, these are some questions we're going to discuss in class. So be prepared to answer these questions when we meet. Okay, and this is basically a flowchart which basically covers what we just talked about. The fact that we have matter, which, as we said before, is anything that has mass and volume. Matter can be broken down into two categories. You have pure substances, and then you have mixtures. Now, under pure substances, you have elements and you have compounds, right? Elements are substances which cannot be broken down into simpler substances by chemical means, while compounds can be broken down into simpler substances by chemical means. And then as far as mixtures are concerned, there are two types. You have homogeneous mixtures, which is a solution, and then you have heterogeneous mixtures, which in which case the two or more components are in different phases. Okay, so that's basically it for chapter 3. So the next video we'll be starting with chapter 4. All right.